Okay, we're going to start today by going over the 10.6-1 notes about polar coordinates and graphing in a polar plane. This first part you should have seen on your, when you were reading through the book. You read those 2 pages and you did the practice packet, so this should be familiar to you. Every coordinate for polar coordinates now is rewritten as an r and a theta. So there's no more x and y's. So this first value is the r, the second value is the theta. And the r is basically, you can think of it like the radius, right, of how far out you're going. So for this first point that we want to plot, A, the radius is 3, and the angle we're at is at angle pi over 3. So if it helps you, we can write on here pi over 3, that's our 60-degree pi over 3 angle. And the radius has to be 3 units out from the origin. So we just count out 1, 2, 3, and that's where we plot our point. So that's point A. I don't know why this seems unfocused. Does that seem better? Okay. No, it still seems blurry. Sorry. Focus is not wanting to focus here. Is that a little better? Okay. The next point has a radius of 4, and it's at negative 5 pi over 6. So negative 5 pi over 6, we have to go in the counterclockwise direction. Negative 5 pi over 6 is down here, and a radius length of 1, 2, 3, 4 out from the origin. That would be point B. For point C, we're at negative 2 for a radius length. The angle is at pi. So if I go around, the angle is here at pi. But instead of coming out toward pi, positive 2, I go the other direction. So it's still along the line, the same line as pi, but it's going the other direction, negative 2, and that would be point C. Point D, negative 3, with the angle 3 pi over 4. So here's 3 pi over 4, and the angle, though, is negative 3. So along this same line down here, I go negative 1, 2, 3. And there is point D. And then the last point E, negative 1, negative pi over 2. So again, negative pi over 2 would be down here, but then I want to go negative 1, so I'm going actually up in the other direction, and that would be point E. And there you have all 5 points. Again, if you're having trouble with this, look back and in the book on those 2 pages that you did for homework last night and at the practice packet. All right, you can also name each polar point 3 different ways, or 4 different ways actually. So I'm going to redo these ones. Let me see if I can get that focus better. Okay, give 3 different names for each point. 2 positive and 2 negative r values, including the original. So I want 3 here. So basically what's going to happen is the original is positive r, so I'll have one other positive r, and then the other one will be a negative r, and then the last one will also be a negative r. So here I have a negative 2, I'll have 2 negatives, and I'll have a positive, and I'll have positives, 2 positives, and a negative. For me, it really helps to actually graph these and find out where I am. So for this one, 3 pi over 4, I can just come up here and look at it. Pi over 4 is here, and 3 would be at 1, 2, 3. So this is that point 3 pi over 4. So for this point, 3 pi over 4, what's another way to name it? Well, it was still a positive 3. I just would have to change the angle. So what would be another way to name this angle without saying positive pi over 4? I want to go in the other direction, and that would be the same thing as saying negative 7 pi over 4. Okay. Now how about the negative r's? So negative r's really would have to start with this angle over here. This angle here we all know is 5 pi over 4 in the positive sense. But if I go in the negative direction, this would be otherwise known as negative 3 pi over 4. Let's do the same thing for B. Negative 2 pi over 6. So where is pi over 6? Well, pi over 6 we know is here. Negative 2 would be over here. So what's another way to call that negative 2? Well, instead of calling this angle pi over 6, I would just rename it as negative 11 pi over 6. And then if it's a positive 2, well, I could just rename this angle. This is the same as 7 pi over 6. Or, as we already saw from a previous problem, this is the same as negative 5 pi over 6. Notice that in the end I use all 4 of the pi over 6 values, just as over here I used all 4 of the pi over 4s. Same idea with this. I'm going to use all 4 of the pi over 3s to do this. So 4 negative 2 pi over 3. So negative 2 pi over 3 is going to put me here. Right? This would be negative 2 pi over 3. Then I want to go positive 4, so toward that 1, 2, 3, 4 would be this point right here. Another way to name that with a positive 4 would be the positive angle, so this is the same as saying 4 pi over 3. Negative 4, the other direction, would be the same as pi over 3. Or if I wanted to name this in the negative angle sense, going counterclockwise, that would be at, negative 5 pi over 3. Okay, as you can see, the importance of knowing your unit circle still comes in very handy. Relationships between polar and rectangular. So in the past, we've always named things with x and y. That's considered rectangular. All right, so rectangulars are your x's and your y's. Polar are now going to be your r's and thetas. So the way that we're going to shift these is we're going to use a couple of our identities here. Cosine of theta, if we look at this picture here, as we know from the experience from last sections, this x value here in our unit circle is just cosine of theta, right? If it was a unit circle of 1. But since it's not a unit circle of 1, we would rewrite this as cosine of theta over r, right? So it would be adjacent over hypotenuse. So cosine of theta would just be x over r. And therefore, if I just multiply by r, I have that x equals r times cosine theta. Similarly, sine of theta is y over r. And this just goes back to SOHCAHTOA. If you don't get this, go ahead and do a little SOHCAHTOA here in your triangle, and you'll catch on. So then I multiply by r, and I get r sine theta. These are going to be our conversion factors. So anywhere you see an x when you're switching from polar to rectangular, you'll replace it with r cosine theta. Anywhere you see a y, you'll replace it with r sine theta. For rectangular to polar, we know that x squared plus y squared, look here, Pythagorean theorem, a squared plus b squared equals c squared. So x squared plus y squared equals r squared. If I solve that for r, I get that r equals the square root of x squared plus y squared. Just take the square root of both sides. Tangent of theta would just be y over x, right? And therefore, theta, when I go to solve this, would be the inverse tangent of y over x. Okay? Inverse tangent y over x. So again, this is from polar to rectangular. We'll use these conversion factors. From rectangular to polar, these will be our two conversion factors. So let's practice. Example 3. So if the polar coordinates are 5 and pi over 6, this is your r, this is your theta, what are the rectangular coordinates for the same point? So I'm going from polar to rectangular. So I just want to replace use my two different equations. So the first equation I'm going to use is that x equals r cosine theta. Well, I know that r is 5 and that theta is pi over 6. So I just plug those in here, and I get that x equals 5 times the cosine of pi over 6. And we all know that the cosine of pi over 6 is root 3 over 2. And so when I simplify that, I just get 5 root 3 over 2. Same idea for y. Y is just going to equal r times the sine of theta. So again, I plug in those two values, and I get 5 times the sine of pi over 6. Sine of pi over 6 we know is 1/2, so y just equals 5/2. And the way I write that is in a coordinate, because it's x comma y, so I literally write it as an ordered pair, 5 root 3 over 2, and then 5/2. And that's my coordinate. So I've now gone from polar to rectangular. This is my x and my y. Let's go back the other way. This one gives you the rectangular, the x and the y, and it wants me to go to polar, r and theta. So I'm going to use my other formulas. There's a couple ways to do this. The easiest way would be to start with x squared plus y squared equals r squared. Well, here's x and here's y. So let's just plug those in and see what we get. So I take this here and this here. So I have 3 squared plus negative 3 squared. I get 9 plus 9. And r is just the square root of 18, which when we simplify that, because we always simplify radicals, is 3 root 2. So I figured out my r, and now I'm looking for theta. Okay, so how should I figure out theta? Well, we did have a couple formulas on the other side, one of which was tangent theta is y over x. Again, since I have x and I have y, I can just plug those in here. So tangent of theta will equal negative 3 over 3. When that simplifies, I get negative 1. Well, when is tangent equal to negative 1? I should have lots of answers for this, right? Theta, if we go to our unit circle, when is tangent equal to negative 1? Well, tangent equal to negative 1 is either up here, right, or down here. Right? Those are my tangents, they're negative. So that would be 3 pi over 4, or down here at 7 pi over 4. And I could also name those negatively, right? So I could go in the negative direction. That would be the same as negative pi over 4. And this one up here would be negative 5 pi over 4. So those are my 4 different options for theta. So really, depending on how they tell you to do it, this said name it at least 3 different ways. Well, really, we've got 4 different ways right here. There are a lot more ways to name this. Oh, we got to think about positives and negatives for a second. Hold on. 3 root 2, negative pi over 4, 3 root 2, negative 5 pi over 4. Something's wrong here because a couple of these r's need to be negative. Over here, when we took the square root of both sides, we forgot to do positive or negative, right? And so there is a plus or minus involved. So let's think about these. At 3 pi over 4, I'm at positive, right? 3 root 2, but I actually want the point. Where is this point? This is 3, negative 3. 3, negative 3. Uh-oh, that's in quadrant 4. So I want the answer that's going to represent quadrant 4. So at 3 pi over 4 over here in quadrant 2, I have to make that a negative r in order to be down here in quadrant 4. Ignore that. So that should be a negative. Same thing for this one. No, that one's okay, right? That one should be positive because that's quadrant 4. Negative pi over 4 also in the quadrant 4. But negative 5 pi over 4, again, I need to flip that, make it negative so that I'm coming down to quadrant 4. So be careful with positives and negatives for r, and as well as your different ways to name theta. All right, let's look at this. We have a little equation here. R squared equals sine 2 theta. We want to convert from polar to rectangular. Write your answer in a form equal to 0. And we'll practice this a little bit more tomorrow. But the way we want to replace stuff is by things that we know, right? Well, we know that r squared was equal to x squared plus y squared. So I can start here with r squared being equal to x squared plus y squared. Sine of 2 theta we know is 2 sine theta cosine theta. Can't forget those double angle formulas. And now I need to kind of solve this. I'm thinking, what should I do? What should I do? Well, I do know if we go back, right, up here we had these formulas, right? R cosine theta was equal to x, and r sine theta was equal to y. So I want to try and get an r sine theta and an r cosine theta. Now notice I'm missing the r's in here, but if I could get a little r in here and a little r in here, then I could replace those with x and y. So how do I do that? Well, I just multiply by an r and by an r. And if I do something to the right of an equation, then I have to do it to the left of the equation. And I'm just going to rearrange stuff over here, so I'll have 2r sine theta times r cosine theta. I just kind of move those over, right? Because now r sine theta is equal to y, and r cosine theta is equal to x. So on the right, I have 2xy. When I'm going to rectangular form, I want only x's and y's in my final answer. Okay. Well, so far on the right, I'm good. Now on the left, let's see what happened. Well, this gives me r times r, which is r squared. What is r squared? Well, r squared we know is x squared plus y squared. So now I have x squared plus y squared times x squared plus y squared, and I can FOIL this whole thing out. Now I'll get x to the 4th plus 2 x squared y squared plus y to the 4th. Now I'm almost done, but the directions did say write the final answer equal to 0. So I just need to move stuff around so that I can get this whole thing equal to 0. And I'm done. I have successfully gone from polar r's and thetas to rectangular all x's and y's. Let's go the other way. Convert from rectangular, notice it's all x's and y's, to polar, only r's and thetas, expressing r as a function of theta. So in the end, what that means is that it'll be r equals something. Assume that a is just some constant. All right, so looking at what we have, what do we know here? Well, I see this x squared plus y squared, that's when we're going to become familiar with. That's equal to r squared. I'll just bring down the ax. Same thing in here, this x squared plus y squared is just r squared. So if I replace that, but then I'm taking the square root of it, so square root, so I just get a times r. And we're getting there, because now I just have a bunch of r's, but I still have this pesky little x. And what can I replace x with? Well, there was that equation up there, and on the other page too, r cosine theta. Bring down your a, bring down your r squared, ar. And now the last part here is just a matter of moving stuff around, because notice I have only r's and thetas, that's what I wanted, but it says that it has to be r as a function of theta. What this means is that it'll be r equals blah, 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 something. So I basically need to solve this equation for r. So the first thing I'll do is bring everything to one side, and then notice that all of these do have a common factor of r. And so I'm trying to solve this here. Factor out that r. I'll be left with r plus a cosine theta minus a. And now I can use zero product property, r equals 0, or r plus a cosine theta minus a equals 0. Solve this for r, and you get r equals a minus a cosine theta. And so I end up having two possible answers, which is fine, and we'll talk about these later as to why we get two and if we have to check both. For now, you want to solve for both. Don't just divide by r and have the r disappear, because then you're not exploring this case where r could equal 0. So I do want you to actually show that as one of your possible answers. So sometimes when you're going from rectangular to polar, you could have more than one answer. And that is it for your 10-6-1 notes. A copy of these is also online if you'd rather refer